welcome to the House of ZK Radio, which is a focused podcast and media channel exploring everything ZK, zero knowledge. I'm Alice, education lead at ZKM. Today I'm joined here with co-host Pavel, who's DevRel lead at ZKM, and our very special guest, Sylve, co-founder and CEO of Hylé. So thank you so much for being here today, Sylve. We're very, very excited to have you.
Happy to be here.
Yeah, thank you. I'm wondering, Sylve, if you could first start off with an introduction of yourself and maybe a walkthrough of your journey. I know that you co-founded several projects like Brick, Dojo, and now Hill, and then you were also involved in several other projects like Starknet and Ledger. So I'm wondering if you could walk through your journey through the Web3 space and also talk a little bit about the why behind your involvement for all of these projects and how it shapes your vision for the space today.
Absolutely. So first of all, thank you very much for hosting me in my thinking cap over here. So name is Sylve. I started the whole journey in crypto because I was a raging libertarian from the age of 14. So you get very quickly into this whole area. So I like to say that contrary to most people, I came for the revolution, but I stayed for the money rather than the opposite. I started working at Ledger. I stayed there for 3.5, 4 years. I was product manager on the enterprise solutions, so I learned everything I know about wallets, custody, security, and already getting some glimpse of programmable cryptography thanks to the internal security team at Ledger. And after that time, I decided to build my own company. So took my co-founder Lancelot with me and raised some funds from Fabric Ventures, and we built first in Fabric Ventures, and we built Brick, which was the first, I think I can claim that, the first live protocol on Starknet mainnet. So back in the day, we wanted to do something within the NFT and the on-chain gaming scene, which at the time didn't even have the name on-chain gaming. It was right around the time that Dark Forest came around. And so Brick was a composability system for NFTs built on-chain. Basically looked like Lego, but running fully on-chain. And so that's how we got into Starknet. We were very, very early there. So early that back then, Stockware was paying the transaction fee. So when we launched onto mainnet, we cost them 20K, which got me the funniest DM I ever had from Uri, the CEO, who's like, "This is great. We're seeing usage, we're seeing traction, but we're going to have to do something about those transaction fees." And the longer we spent on Starknet, the more I grew fond of the community. I got involved into governance, and we ended up co-creating with a band of fellow builders in the then nascent on-chain gaming scene a game engine called Dojo, which is fully built out in Cairo. So everything, the whole thing that got me to building Hylé was that I was always very interested in the technology itself of blockchain. But the more I researched it, the more I realized that, hey, actually there's this tiny little branch that is like forking out, which is revolving around ZK and more broadly programmable cryptography, and that seems to unlock a lot of things. And that's what led us to building Hylé. As we went on to build Dojo, we realized that, hey, actually, you don't exactly need to do everything on chain and run everything with the same shared execution environment because it's very expensive and it's very cumbersome. How about we just do the hard thing outside the blockchain and just bring a little tiny piece that gets verified on chain? That was basically the whole logic behind what we were doing at Dojo. And the more we researched that, the more we realized that, hey, actually, there's a whole branch of applications that you can only do if you do it this way, but the blockchain is just not quite tailored for these kinds of applications. It's right, you're trying to shoehorn something, like put a star into a square. And so that's why we came around to building Hylé. Hylé is a network that is entirely focused on providing the best experience for what we call provable applications, which are decentralized apps that are leveraging to the maximum all the tools that they have around programmable cryptography. So it can range from on-chain gaming to, you could run an AMM basically as a provable application, but think of it as the mental model being everything is a rollup and everything is provable. Happy to talk more a bit about that.
Yeah, sounds great. And it's really great to hear that progression that you had from first getting your first taste of programmable cryptography, and then going on to on-chain gaming, and then founding the projects, and then finally co-founding Hylé right now. So really interesting to see that progression go along. I'm wondering, in terms of the tiny piece that you mentioned that gets verified on chain. I kind of want to focus more on that for this question, but I'm wondering if you could speak a little bit about the kind of limitations with traditional, like say, proof verification methods. A lot of proof systems, and even for us at ZKM, we deploy the verifier contract on Ethereum. So I'm wondering if you could talk a bit about maybe limitations, drawbacks, trade-offs with our traditional kinds of proof verification methods, and how Hylé addresses this.
To answer that question, I'm going to go back in time a little bit, which is, I think it was around 2011. Forum post by Satoshi Nakamoto on Bitcoin Talk, talking about a tiny little branch of mathematics called zero knowledge proofs. And he goes on around saying, this is a really cool innovation, and if it was practical, if we could actually use it, we would add this to the protocol. This would make for a much more efficient Bitcoin implementation. Unfortunately, the tech is just not quite there, so we'll have to do without it. And I really liked that forum post because I think it was very cognizant of the potential that the technology had, specifically in a blockchain setup. And so the crux of the issue that you have with blockchain is that you have thousands of computers redoing the exact same computation over and over again. And that's how we manage to achieve what we call trustlessness. I am sure that Alice has 1 ETH on her account because I'm able to trust that that computation has been executed and verified by the consensus. But the way that we do this is by having thousands and thousands of nodes redo it. ZK and provable applications in general pinpoint specifically that problem by, it's a very ham-fisted solution to the problem, which is, okay, let's just not do the hard part on the blockchain. But in order to get there, the middle point where we're at right now is Turing-complete virtual machines. If you look at Ethereum, Ethereum is the world computer. It ships a VM, the EVM. And so everything theoretically can be built on the EVM. And so, Alice, as you were mentioning, what you folks do is that you deploy verifier contracts. You take a specific proof system, you write the verifier contract in Solidity, then you deploy it on Ethereum. So it's very akin to any type of program that you would be running on top of a CPU. The approach that we're taking at Hylé for this is only focusing on proof verification. So the nodes don't have to run the EVM, and on top of the EVM another application. What the nodes at Hylé are doing is that they're just verifying proofs. They're running native Rust verifiers of Paulus consensus because that's the only thing that the network does. Very oddly, Hylé does not ship an execution environment. The thing that you can do on Hylé is verify proofs, but that's the only thing that you need to have an application. Basically, if you look at the rollup, what rollups do on Ethereum is verify state transitions. Arbitrum went from A to B. Stocknet went from C to D. As far as Ethereum is concerned, that's the only thing that they see. In the context of provable application, everything works like this. I have an application is going from state E to F, and I'm going to send the proof that and the new state of the application to Hylé. And Hylé is going to say, okay, well, that's the new state, that's the proof, you're good to go. And you do not require the nodes to run the very expensive computation on top of this, which opens up extremely exciting possibilities because you're not constrained by the execution environment. On Ethereum, basically, you want basically any programmable L1 at the moment, you're limited by the smallest node. So it's very logical that people would ask, oh, why don't we just make the blocks bigger? And it's a very reasonable thing to say. Let's just do the bigger thing. Let's just add more bigger computers. But if you do this, it defeats, that's like the blockchain trilemma, it defeats decentralization because it means that only the big computers can participate in consensus. And ZK breaks this. You can verify extremely large proofs on consumer hardware, and you're putting you're allowed to have like segregation of duty between the person who's doing the work and the person who's verifying the work. And I think it's a very what Ivan Illich, the philosopher, would call a convivial tool. It's a tool that anyone can use. And in the context of, let's say, like big blockchains like Solana, well, it's not very convivial because you're trusting that the very big machines are going to run the network. What's great with ZK is that you can have these massive computers do the very, very hard work, but you can still, and that can be centralized and that can be like very efficient and very VC funded. But the network can be very decentralized, run on a smartphone, and have oversight of what's going on the other end. And that's what we're doing at Hylé. So we're a blockchain, we're a Net1 blockchain, that does a lot less stuff that normal blockchains do. But because we're tailor-made for ZK, we don't need to ship a VM. We don't require that. You can come in with any type of programming language as long as it's provable. In order for you to have an application on Hylé, it's very easy. You just say, okay, that's just how you're going to be able to verify the program that's running.
Yeah, sounds great. And I do like the very specialized focus that you guys at Hylé have. So just with the proof verification aspect, not requiring nodes to run a separate execution environment. So really do like that very specialized focus. I feel like in our current landscape, ZK landscape today, we're seeing a trend with a lot of projects becoming very specialized and very focused on different aspects within the proof generation verification processes, which is really great, so that we can reduce costs and then increase scalability, and then, as you say, have ZK become a more convivial tool, so something that everyone can use, even beyond Web3, which I'm personally very excited about. I'm wondering, just on that topic, I'm wondering if you could speak a little bit about your opinion on what is exactly preventing ZK from becoming mainstream, both on the user and developer side, even though we have that mission for making ZK a tool that everyone can use, and even though our proving and verification costs have improved over the years, the demand for it has not necessarily increased at the same rate. So I'm wondering if you could talk a little bit about your thoughts on what's preventing ZK from becoming more widely adopted, and maybe some like next steps that we could take to address it.
The comparison that I like to make for ZK is to compare it to the early steam engines. So we know the steam engine, it was used to power the Industrial Revolution. It was used in steamboats, factories, specifically the textile industry, but it didn't start off there. The first area where the steam engine was used was very peculiar. It was to pump water out of coal mines. And we're talking end of the 19th century there. And that sounds like a very odd place to use the steam engine. You'd think, okay, why didn't people just use it everywhere? Because it's such a good technology, just like we're thinking about ZK right now. Like, why isn't everyone using it right now? And the reason is that the early steam engines were so crude, so inefficient, so janky, that the only area where we could apply them, where the inefficiencies didn't really matter, was literally next to their power source, just to pump water out. And it was a great use case because it meant that we could mine more coal and therefore use more steam engines. And then we applied that to, again, it's a very localized thing, that it just so happened that in the UK, at the end of the 19th century, you had a real demand for coal because basically they had cut down all the trees. And so they were in a dire need of another heat source. And second, that it was the hotbed of the textile industry. And the whole industry was bottlenecked by a single movement, which was to spin a thread. It would be really cool if we had a machine that just like goes on and on and on again. And someone, like I don't even remember who it was, had the brilliant idea of saying, "Hey, that very crude thing over there that's getting exponentially getting better as we use it more in coal mines. How about we apply it to the textile industry?" And then the coal and then the steam engine got better. And then someone said, "Oh, it got better. How about we try to like miniaturize it and put it in a boat?" And it goes on and on and on. For ZK, we're talking about the technology that was first put in a paper 30 years ago. It's still quite early. And even probably like 12 years ago, it was taking hours, days to prove the smallest amounts of computation. And the actual first, it was actually a fun thing. I tweeted out, had anyone seen a use case for ZK outside of blockchain? And Elie Bensasson from Starkware answered, nah. So I got mocked by one of the fathers of ZK, which was fun. And I do think that's because the first real use case that we saw for blockchain, for ZK, was blockchain. Because it was the only area where such an still inefficient sort of technology could be applied and generate massive results. It was to scale Ethereum. That was the first use case. And by doing it, we invented new proving systems, Binius, Planck, CircleStark. We had new tools that allow you to use them. It was Starkware had a head of algebra, and Cairo, their programming language, and probably one of the most used programming language for ZK, was first an internal tool for them so that they didn't have to like write the polynomials by hand. So the proving systems are getting better, the tooling is getting better, to the point that now we have ZK VMs. You don't even need to think. Eventually, you won't even need to think about what type of tool you're using. You just write your code, and it will be provable. And I think what you're referencing there, Alice, is the how do we go from the coal mines to the textile industry? And in my mind, it's going to be provable applications. It just fundamentally lowers the cost of trust. It means that suddenly I'm able to produce a proof that I'm employed at Goldman Sachs, and therefore someone is going to give me a loan on the blockchain thanks to this. It lowers the cost of KYC, lowers the cost of verifying, and not only in the computational sense. I don't need to pay a KYC company $200 to get your FICO score. I can just get a ZK proof from you generated by another third party that you're legit and you have good credit. And I think that's going to be the Cambrian explosion for this actual usage of ZK. And I agree with you. I'm quite excited for that thing. But I don't quite know what it will look like. But that's what us at Hylé want to help develop.
And just to follow up, so I noticed that within your projects, Brick, Dojo, as well as Hylé, um, or in a sense Hylé, I guess not the main focus, but Brick and Dojo are both focused on the gaming aspects, like Metaverse gaming, and then with Hylé, that is focused on the lower cost of proof verification. So I guess would you say that through gaming, like that would be a great use case for bringing on board more people, creating more apps, especially in this that scalable factor, where it's less, I guess, the security matters, but matters at a lower aspect than the cost and the speed of proving.
You're absolutely correct, and I don't think we would have ended up with the same beliefs that we have right now had we not worked on that specific subset of the blockchain world. A French author said, Julien Gracq said, there is no worse waffle maker than the tragedy in 5 acts. He was talking about theater plays. And I think for blockchain, this is DeFi. DeFi is the one thing that has PMF in blockchain. Stable coins are fantastic. and they've become the de facto standard for sophistication of smart contracts, for dApp development standards. But DeFi apps have very specific requirements. They must have very low trust minimization. Like it must be decentralized. It must have very high availability and very high censorship resistance. Games are quite the opposite. Gamers, no matter what they say, are okay with the like 2 hour downtime. You're not saving lives, you're not training millions, you're sending your fleet to attack an enemy. But as you mentioned, you're going to make the trade-off of saying, oh, I just want this thing to be very fast. And so the thing that happened in the gaming ecosystem on chain was that we went from let's be minimally on chain to the point that you only have the assets. These are the Axie, the Sorare of the worlds, to let's put everything on chain. And like the pendulum is swinging back in full force in the opposite direction. And that's how you get the on-chain gaming scene, which is very experimental. It's an extremely shout out to the on-chain chats and Autonomous Anonymous crew. I love you all. It's a fun crowd of people that are really pushing the EVM, pushing blockchains to the maximum and trying to do things that are basically illegal and that no one has really tried to do before. And it's very difficult, because the standard so far was just, DeFi. So you can see in a lot of on-chain games that they kind of look like DeFi. You try to like move resources from there to there, and shout out to Bowden from Ethereum who once said to me, if your game is not complex enough, it's just going to become MEV with extra steps, and this lives in my head rent free. One team that I really like, two teams on that front that are really pushing the narrative there are Playment and Topology. Two are really good friend of ours at Hylé, and what they realized is they both started from very on-chain. The Playment team are a team of gaming veterans, and the Topology team were very early Stocknet builders, and they started and they tried to cram as much logic as they could on chain, but they eventually realized that it just doesn't work. It can work for some type of games, but the type of games that the Playment team had built previously, like Fall Guys, it just doesn't work. You need something that just goes faster. It's not the good affordance. So what they're looking at now is kind of the same train of thought that we've been having at Hylé for a while now, which is let's just do the hard thing, just not on the blockchain, and sometimes go on the blockchain when it matters. It sounds very dumb when I say it like this, but what it ends up being is, for instance, in the context of Topology, they're using CRDTs, which are conflict free resolution data types, between players just to have a little game. And there's very low censorship resistance. You can kind of cheat, but you always have the option of going back on chain. And that's the great thing in my mind that programmable cryptography gives you, is the ability to go on chain. You don't start by requiring people to have MetaMask to go on chain and pay dollars of transaction fees. You give the option of going on chain. And that's the mental shift I think that a lot of people are experiencing now. And that's why we use the term provable. You're not on chain, you're possibly on chain, and that gives you a lot of reassurance in terms of censorship resistance, but it's not a waffle maker where we'll not require you to be on chain at all times. And it opens up a whole new realm of possibilities. All of a sudden, hey, it's great, I'm back in Web 2. I don't need to require my users to have a wallet. I don't need to explain to them what's MetaMask, what's a gas fee, and I don't need to have a paymaster system. They're just going to play. And maybe one of them has a high score and is willing to pay $5 to have it verified on chain and inscribe it as in a provable leaderboard. That's what really excites me, because these are the things that are just not possible on the blockchain. Let's not forget that in end of 2017, beginning 2018, Ethereum was brought down by digital cats. It was always the games that that turned everything to shit. And that's where I think it really forces you to rethink things very differently.
Yeah, definitely. And really love the idea of having that choice. So providing that, as you said, providing the option to go on chain. Not everything or all the steps needs to be on chain, but providing users with that choice of going on chain or not, I think is really important. And as you said, could extend even beyond Web3. And in addition to just the on-chain gaming use case, I'm wondering what other use cases, Hylé and maybe those that are just general ZK related, are you really excited about and you see the most potential in?
I'm very excited about the ZK Passport in general, or Open Passport, and all the teams working on that front, because it's when I pitch ZK to people, they don't really quite get it. Like, what do you mean? Like, verified computation, what does it mean? And I just show them ZK Passport and Open Passport or Rarimo. It's like, wait, you mean I can like prove to you that I'm a French citizen without revealing my data? And that's 1,000x improvement over whatever solution we have right now. There are a lot of discussions right now in Europe around should we gate certain contents to adults, and it's going to be mayhem. We will require people to have KYC, have credit cards, and like these teams are following the debates very closely, and they see ZK mentioned, and I think that's a fantastic liftoff. A group of people have banded around this idea of how can you use programmable cryptography to build decentralized applications and like use the right tool where it works, not necessarily fully on chain, as we were talking about before, like using blockchain when it really matters. So part of that group, we call ourselves we call that concept trust infrastructure, revolves around like the people at Tong.gg who are working on they have a tool called Speakeasy, which is a way to have private forums that you can only get into if you have a proof that you're like a gamer on something. And it's really cool. I think these are really great affordances because the mental model is on the blockchain that everything should be trustless and you're not trusting anyone. And so you either in the Web 2 world where everything is centralized that you're like fully trusting the company that's operating it, or you're in the blockchain world where everything is trustless and I'm not trusting you, blah, blah, blah. But you have got nothing in between. And what the trust infra people are pushing for is there a way to have progressive discoverability of interactions on the internet? For instance, I've got to know you over our last exchanges. I'm willing to disclose more about myself, where I live, etc. But on the internet, it's either you know my full pedigree because I'm shouting on Twitter or nothing. You've got nothing between the 500 million tweets a day on Twitter and a closed group chat. And what I love about programmable cryptography is that you have layers of interaction in between. Maybe we've interacted 5 times already, so automatically you will have access to more information about myself. And that's why I think is splendid, because it goes against the global enshittification of the internet, where you basically algorithm are rolling a lot of things and it's just not fun. But how do you manage folksiness and closeness at scale? That's what really, really interests me. And I think what the Cursive team has been doing, what the Tong team has been pushing, are fantastic tool to push that narrative. So I'm excited about programmable cryptography for human interaction, trustful interactions.
I like how you focus on identity and in the cases of reputation. So you can learn a small subset of information, but that would allow you to access different activities or different actions across different ecosystems. And so I think like having a open login and extending that from your passport or just any type of general authentication without relying on a third-party authentication provider, so someone can use open. I think like right now you have OAuth where you can log in with your Google account, but then in the future we can see that you can have a proof of anything, and then you can use that as a means to log in. ZK email is working in a similar direction with that. So really cool to see these use cases in terms of the authentication as well as the verification of identity.
That's the thing that really interests us at Hylé, and these are the affordances that we have access to by virtue of being ZK first. What I mean by that is, like, very concrete, one of my pet peeves are wallets. I've come to absolutely hate wallets, and I've worked on them for a good chunk of my professional career, and they're horrible. I mean, it's still a disgrace that it's 2024. The Bitcoin white paper was in 2016, and whenever I want to onboard anyone on the blockchain, it's always like, okay, so you're gonna have to download MetaMask, and then you're gonna have to. It's ridiculous. It is ridiculous at this point. Lucky for us, like, we're moving towards the right direction. A massive first step was a kind of abstraction. Okay, cool. Now we can have more logic, but you're still like twisting the arm of everything. The former Ledger colleagues of mine are building Smooth, and they're the guy responsible for building the most used library for SecP256R1 verification. What is this? You've got something on your phone, and most smartphones, called WebAuthn. It's also called passkey. It's a passwordless authentication system. So a lot of systems are now shipping with it. You can go on Facebook, you scan a QR code, then on your iPhone, you look at it, Face ID, you connect. Easy. No passwords, nothing. Would be great to have this on chain. That's fantastic. But that curve is not on the EVM by default, so you have to code it in Solidity, then over and over and over again. With ZK, you don't even need to think about any of this. Like, if you're on Hylé, you're only verifying proofs. So we don't even have the concept of like verifying signatures or anything. Any program can be used to verify your identity. So we shipped a little demo for Hylé called Vibe Check. It's like you get tokens if a ZKML model asserts that you're smiling, and we're using WebAuthn. And the way we're using this on Hylé is we're verifying the proof of a WebAuthn signature. And that just means that you can get anything. You can have username and password. You can even have things where like anyone with a French passport can enter this application. It's a lot more expressive than what you have right now with just smart wallets or programmable wallets. And that's what really, really interests me. And you can just compose them. Okay, it's very easy to have access to the same things that you have in the blockchain right now. You can have the proof of an ECDSA signature. Bing. You have MetaMask. That's it. It's very easy. But then you can pile them on. Okay, you need to have an ECDSA signature, then a proof that you're a Thai citizen, then a proof from your passport that you're over 6 foot. And then you're able to transact a token. I'm using that example because that was something we talked about with some people during Trust Infra Week. We were thinking about how to produce a zero knowledge proof that someone works in finance, is 6'5", and has blue eyes. Is it because it's a meme? And how is it possible to create a zero knowledge proof of this? Because I'm willing to find that person. I think there's probably someone that fits the criteria, and maybe someone is motivated as well, and they put a bounty out, and they say, okay, if someone complies with this, produce a proof that you're working in finance, you're 6'5", and you have blue eyes. This is just the playful type of things that you're able to do with programmable cryptography, and I'm just all for it.
Yeah, absolutely. And when you first mentioned like this 6 foot, the first thing I thought was that meme. So it's so funny that yeah, we can even play around with these kinds of like features, but at the same time, it really shows really the extensibility that ZK can go towards, and any program can be proven and verified, and I think that's very powerful. So thank you for bringing that up. I'm wondering if we could transition more into speaking a little bit more about the provable apps, which you mentioned can extend, or it's like a subset beyond ZK, beyond those that are just on chain, and could have the potential to extend to Web 2 based applications. So I'm wondering if you could speak a little bit about the types of applications that can benefit most from provability. So like with Dojo, you talked about kind of extending provability to gaming, but I'm wondering if you could maybe talk a little bit more about some other types of applications that you see could really benefit, and maybe those that are in the Web 2 area as well.
What interests me with provability is that, as we mentioned before, it's you can look at ZK as like a magnificent API between on-chain and off-chain, and it's great. One thing that I'm very excited about with provability is, and I'm taking a page out of Crane from Asula and Bedlam research there, about the idea of on-chain and off-chain domains. He has a very nice framework for thinking about different things happening in the blockchain. We talk usually about rollups. Like rollups are an extension of Ethereum, and they just post state and verify their state back on Ethereum. And Crane has this funny idea of saying, well, Binance is a rollup. It just has different trust assumptions. It's very stateful, but it has very low like trust minimization. Like you really, really have to trust Binance. But basically, as far as Ethereum is concerned, Binance is a rollup. You have receiving addresses, and Ethereum has no idea what's going on the other side of the spectrum. And once I started thinking about this, I realized, oh, with provability, it would be very easy for Binance to become a rollup. They just post a validity proof of a state transition of their system, and they would not even need to rewrite everything in Warwick Hiro. They could do this using a ZK VM. This will be extremely inefficient, but maybe they just post their transition, their validity proofs every week, and that's it. And once I started thinking about this, I realized, oh, okay, cool, we can finally put banks on chain. Because the way we've been trying to do this for all this time has been very idealistic, I think. Because we've been trying to put the banks on chain for a really long time, and the way we've been trying to approach it is going up to Goldman Sachs, like hand on the shoulder. You've been doing like rubbish all this time. You should trash everything and rebuild it on chain. Here's solidity. And it's very difficult to transition people on chain in that way. It's very tricky. And that's why it's always been difficult. And we even have the term to go on chain, to migrate on chain. It's always, you need to pack up your things and go into the future, or you'll be left behind. And this has been a tough sell, to be quite honest. So we focus on very blockchain use cases. So yeah, what I'm excited about with provability is normal Web 2 systems, rather than rewrite their entire systems in a specific language and adapt to the blockchain, can just use a little tiny adapter called ZK to go on chain. It's like a very smooth continuum between Web 2 and Web 3. In the future, I really do not think that we will even think about rollups, or we talk about rollups now. Basically, everything in the future will be a provable server, and there will not be, a bit like what I was saying before with Binance, it's going to be a spectrum of different decentralization options. So I can definitely see Web2 businesses decide to go on chain just by virtue of running a ZK VM and settling back on Hylé every week. And it's great. Then you have access to the global state, to verification. It's very different from the ideal version that we had of migrating everyone on chain. But in my mind, it's a massive improvement over the status quo and something we should strive for. So that's what I'm very excited about with programmable cryptography.
Yeah, absolutely. And very much like the point that you made about normal like Web 2 based systems not needing to rewrite their entire system, and instead having ZK as a way to kind of onboard themselves to go on chain. So I really like the comparison of you likening ZK to an adapter, kind of like a means for those to go on chain. And I see a lot of potential in that. I'm also very excited. And the potential for these, finally putting these banks on chain is also really exciting. And as you said, one way could be like running on a ZK VM, settling in Hylé. I'm wondering if we could go more into that aspect. So if you could provide some more insights on the process for someone who wants to verify their proofs natively using Hylé, and if the process, like for say, like a ZK VM to use Hylé for the verification. I'm wondering if you could talk a bit about kind of the steps within that process and how it affects the whole proof life cycle pipeline for ZK VMs and maybe other systems who want to settle on Hylé.
We can take a concrete example. Let's take a stablecoin, for example, running on Hylé. Currently, how stablecoins work on Ethereum L1 is, as a user, I'm going to craft a transaction, send it over to an Ethereum node. I will pay transaction fees. The code will be run by validators, validated by the network. Then the state will be updated, the application will be updated. And then what I will see on my front end is, okay, my balance has changed. Hylé doesn't work very much differently from this from a user perspective, but in the background it's very, very different. The way it would work is the user would craft a transaction, basically. Just go on the front end and say, okay, I want to do this. This will broadcast the transaction to Hylé. At this point, Hylé just receives what we call a blob, and the blob just says, okay, Bob is sending $2 to Alice. At this point, we don't know if that transaction is true or false or whatever. What's going to happen next is, on Hylé, the smart contract for the stablecoin, the ERC20, it's very, very simple. You just have a name, a proof system, and a way to verify the program. So what you can do next is a prover comes in, looks at the Hylé blobs and say, okay, here's a blob. You know what? I'm going to try to run it. They run the blob, they generate their proof, and they say, okay, it works. Then I'm sending it back to Hylé. I'm updating the state, and I'm getting a bounty. So you can think of it, a comparison that I like to make, if you're familiar with like functional programming, is Ethereum is very imperative, like do this, then this, then this, then this. Hylé is more, here's everything that's going to happen, and okay, now we effect all the side effects in one go. So you can run a Solidity application, a Solidity contract on Hylé. You just have to specify how to verify it. You can run a Rust application on Hylé. You just have to say, okay, use RIS0 to verify this. The great thing with this is that it's not only that it makes it easier to verify the proofs, it's that as a user, as an app, you don't even have to think about it. You're just going to send provable payloads to Hylé. Hylé takes care of sequencing them and say, okay, this one came before that one, a bit like Celestia, and then you're able to know how to verify those programs. So you run the computation, you generate the proof. That's the job for the validators of the network. Then send it back to Hylé. Hylé says, yep, that worked, and then pays everyone. So we very much differ from aggregation layers, for instance, in the sense that we don't focus on verifying the proofs. We focus on abstracting the whole work. We don't even require users to come with proofs. We just require them to come with provable payloads. We like before in the supply chain system. We don't even, what we want is to make ZK as usable as possible, and that means abstracting away that part. We don't want to make proofs cheaper to verify or generate. We want to abstract the whole supply chain for dealing with proofs. You just say, I want this verified. Take care of it.
Yeah. Actually, to add on to that pipeline for proof generation, I was playing a game recently called Beat Saber, and I noticed that there was a high scoreboard and one of the high scores was in the range of like 2 billion. Like it was, I guess uh, what is it, like 32, in 32, basically like the maximum, like 2 billion, 100 million, et cetera, et cetera. And then, so that person obviously cheated because they didn't.
Suspicious.
Yeah, very suspicious because the number two spot was like in the order of like 2 million or something like that. So, um, like in that example, having a way to verify that, or sorry, to prove that the execution of the game was correct, and then sending that proof um, to Hylé, I think would that be? Would you imagine that being the flow for for the pipeline in that way?
I really like your example, and it's been a bit of a growing issue in some communities. For example, there's a type of players who like to play games very fast. They're called speedrunners. So it's that they take any game and then they invent a new game, which is to finish the game as fast as possible. And so they have like their own little Olympic games, like you play Mario 64 on the Nintendo 64, and then you have to get like 120 stars, or you can't use any glitches. So it's like categories, and each of these categories has rules. And an issue that you have with these sorts of things is cheating, because what you're doing is something that is very difficult to manage for multiplayer games, because speedrunning is a multiplayer game. You have dozens of people, probably not even hundreds of people, speedrunning a game, and then according to certain rules, and then sending their game. It's like asymmetric, asynchronous games. The issue is the game is not happening on a centralized server at Nintendo. It's happening on their own little machine. So you're able to trick things, and the proof that you're going to provide is a video. So you have techniques. You can do something called splicing, like you remove some parts of the video to speed up things, and it's very difficult to track. So usually the way people find out is like you did, Pavel, like, suspicious. That player was really bad 2 months ago, and all of a sudden they're number one. That's suspicious. An example that I love is Trackmania. It works the same. It's a racing game, very, very simple game. And I don't know how I fell into that rabbit hole, but there's like a whole drama about like the top players like cheating. And the way they cheat is because the game is played client side. And so they would slow down the game so that they could make very, very sharp turns. And so the way that they found out about the cheaters is that they looked at the replays and they looked at the inputs and they said, oh, well, that's very fast. There's no way anyone could be playing that fast. So theoretically, you could prove that someone has played according to the rules of the game. And that would deter people from cheating, using like modified software, or not respecting the rules of the game. But in the context of the example that you gave, Pavel, about the guy, like the person maxing out the Beat Saber score, is there are limits to what you can prove. What you will have with provability, it's a bit the same thing I was saying about like there's no difference between Binance and a rollup. There's no difference between having a proof and have the person play on a centralized server controlled by the company. In both contexts, the result is the same, that you will be sure that the person has played by the rules. You can't be sure that the person is not using like out of bounds stuff. Maybe the person playing Beat Saber was using a robot, and there's no way ZK can really assert this, and there's no way the centralized server can know that. So there are limits to what you can do there. What interests me there is the possibility to create more rules. If you play with like a centralized server for a multiplayer game, there's like one way you're gonna play. But if you play your game with like 3 of your friends with like a little consensus, and you say, okay, we're going to play according to that rule set, then you're able to verify on Hylé that you played according to that rule set. You verify it after the fact. It's like you're not asking for permission, you're asking for forgiveness. It's like, okay, I've told you I'm going to play like correctly, and then anyone is able to provably verify that you actually played. correctly. And then it really becomes a matter of really setting up the rules properly. Maybe one of the checks can be, okay, a human needs to check this. And you have like a list of people who are authorized to do so. So a lot of issues can be solved using provability, but the crux of the issue is still that people are going to cheat, and that's very difficult to weed out. I was actually talking with David from Playman, who worked on multiplayer games, and said, yeah, I mean, people are just going to cheat at that point. Like,
Yeah, interesting how, well, ZK can't, you can't just sprinkle in ZK and then have it fix all aspects, but just knowing that that you're having a game run in this exactly like enclosure, and you know that it was an authentic version and it was run on an untrusted machine. So, but then someone can add in a tool assisted uh, mechanics and sort of run like something as well. Like you can run the game in the SDK, but then like the
yeah,
inputs to the game can be manipulated in that way. So definitely
absolutely.
something to think about when developing these attestation type systems. So
It's very
thank you for
difficult
sharing
to.
sharing that insight.
No worries. It's very difficult to weed out. I was talking about it with Will Robinson from Alliance DAO, who shared a story about I don't remember which on-chain game it was, that tried so hard to identify bots that the bots just got more human-like to the point that they couldn't distinguish them. And so it wasn't that bad because the equilibrium ended up being that these bots were just not really much better than humans. So so as a human player, you always had someone to play with that wouldn't kill you on the spot or be massively better than you. So that was a really funny side effect. It's always a cat and mouse game.
Yeah, absolutely. And very interesting to see all those kinds of design considerations that you're making behind the scenes as well. I'm wondering if we could talk a little bit more about, I saw with Hylé, you guys are using delayed proving, which I found to be very interesting. So specifically with addressing, say, like two transactions or like happening at once, transaction concurrency, and the idea of you guys splitting that transaction into two different parts. I'm wondering how, if you could talk a little bit more about the concept and the reasoning behind implementing this mechanism, and maybe some opportunities that it can create in terms of like new incentive structures for provers.
The basic of delayed proving is what you're trying to solve there is how do you make sure that proving is not the bottleneck for your network and your application? Proofs take a lot of time to generate sometimes. There was always an overhead versus just running the code. And so when you're dealing with very large proofs, it can mean like sometimes several minutes or hours to generate a proof. It can be very, very inefficient. So the way provable apps work is they run somewhere, centralized server, decentralized server, etc. A proof is going to be generated, then verified somewhere. Basically, a rollup. Everything is a rollup. This is also how systems like Mina work. Mina is essentially only verifying proofs. It's not shipping a virtual machine. So the problem that you run into is, let's take the ERC20 example. I want to send $2 to Pavel, and Pavel wants to send $2 to Alice. These changes, if they happen at the same time, are not going to conflict, because we do know that by the time a transaction gets to Pavel, he'll have enough money to send something to Alice. Let's even assume that we all have like $10 each, so no issue there. If you run in a provable setup, we have two transactions, and the two transactions start from the same state. But the issue is, my transaction, if it gets proved, the state of the application will be this. And if Pavel's transaction goes first, the state will be this, even though the two transactions can run at the same time. This is not a problem that is unique to provable applications. I will say it's a problem that's unique to provable applications, but it's already something that we see all the time in rollups. That's why we have sequencers. Sequencers are responsible for looking at all the little sheeps and say, you get in line. That will be the line that we're going to prove you and verify you. And if you don't have this, you end up with problems with concurrency, and you end up with massive bottlenecks. So how do you solve this? One way of solving this is everything is a sequencer. Every single application needs to have a sequencer. Every single application needs to look at all the transactions and decide what's the order. That's what Mina is doing. And we've decided to do something different, which is delayed proving. So the way delayed proving work is somewhat similar. We ended up with a design that is somewhat similar with what Monad is doing with what they call deferred execution. It's a very simple solution. So I have my transaction, Pavel has his transaction. Rather than generate the proof, then send to Hylé, then update the state, we just send the transactions to Hylé. And then Hylé will take care of the sequencing. So rather than requesting and requiring the apps to sequence, Hylé takes care of that. So you don't need to think about this. This also means that users or applications don't even need to think about proving times. This comes in later. So you solve many problems at the same time. I do think it's the only way you can really solve this elegantly. So what this gives you is extremely high throughput, not having proving as the bottleneck, and solving concurrency issues. So you get like your cake and you get to eat it too. You get all the good things of having a provable application, which is you choose your development environment, you choose your execution environment, you choose the level of decentralization that you want, but you don't run into the pesky problem of every single application needing its own sequencer. You just offload this to Hylé. That's kind of what we're here to do, and you don't think about that.
Yeah, thank you. And oh yeah, go ahead, Pablo.
Clarification question. So are you generating one single proof for the batch of transactions, just like a rollup would do? Or would you aggregate those proofs together and then post that single proof?
This is a design question more for the application. Hylé does not force any single solution. If you look at how rollups do it, for example, Starknet, what they'll do is they will prove a batch of transactions on chain. They aggregate Starknet, then a bunch of StarkX's, and they just roll everything up. For Hylé, the fun thing that comes with this is that finality, when we talk about finality, it means like consensus has agreed that that thing is true. On Ethereum, it just ticks every block. Like you know that all the state transition going from there to there, like finality is every block. On Hylé, it's not every block, it's contract dependent. Because some contracts will have different proof systems than others. So some proofs will come to Hylé faster than others. Maybe one contract is just verifying a gross 16 proof. That's very, very quick. Maybe another contract verifies a Cairo proof or a zkML proof that is much bigger to verify. So the finality of the application depends. There's no concept of global finality on Hylé. It will always be application specific and proof system dependent. So an application could definitely use aggregation. That could completely work, and I 100% see them use this. But this is not something that the network is going to be optimizing for or forcing people to do. I see something. I see this more as a market structure around Hylé than something that we will necessarily encourage from day one. If you look at Ethereum, you now have separation between the people who like build the blocks, the people who propose the blocks, and that came naturally from the set of rules that Ethereum has provided in the beginning. But this was not designed with this in mind. It's just how the market and the infrastructure orchestrated itself around the set of constraints that Ethereum has set. This is going to be basically the same for us. So highly verified proofs, and some of these proofs can be aggregated proofs. So if applications are happy with a little longer time for finality, they can obviously use aggregation, and I definitely see them use aggregation for that.
Yeah, got it. And really like kind of flexibility that you enable to users and giving them kind of the like putting them in the driver's seat and for them choosing like their kind of execution environment, their level of decentralization, any other design considerations that they want, but then they can just offload it to Hylé, and then you guys take care of the rest. So really like the kind of flexibility that you offer to users. But yeah, overall, I just really enjoyed Sylve, all the insights that you gave just on provability with the on-chain gaming use cases, which I didn't really know too much about, but you provided a lot of great insights on more opportunities for programmable cryptography. So really enjoyed all of the insights. I'm wondering, just before we close the session for today, if you have any last thoughts or maybe some advice to the audience.
I think programmable cryptography was born on the blockchain, but in the same vein, to what the character in Interstellar says, like humanity was born on Earth, but it was never meant to die there. It's a bit the same. I'm very excited about all the cool stuff that we're going to be able to do with programmable cryptography and ZK in particular, that may or may not be related to blockchain, and that's what really interests me, and that's why like I'm very happy about what we're doing at Hylé, is because we're giving like the little tiny part that you need to be on chain, and the rest is for you to decide. And it's kind of like an alloy. Like sometimes you just put like 99% of a metal in 1% of another, and everything becomes a lot more stable. I don't think there's been a better time to be in blockchain, but more particularly to be opinionated about what you want to build in blockchain. And it's okay to say, maybe I don't want to be like fully on chain at all time. Maybe just a tiny bit is okay. And what does that expand? What does that allow? That's what I'm excited for.
Yeah, sounds great. And thank you so much again, Sylve, for being here today. We were really happy to have you.
Pleasure. Thank you, folks.
Awesome.